The stagnant pattern continues in Texas. Got northerly flow back in the picture and the moisture feed continuing just off the surface here. Welcome back to Meteorology Lab. Tim Vasquez here again. Figured I'd start this off with a little bit of Florida. Managed to squeak out a little squall line out of this. And nothing severe here. This is just the leading edge of that front picking up a little bit of that moisture just off the surface and getting a little bit of weak thunderstorm activity there. Just how strong is the thunderstorm activity? If you're curious and you just don't have access to watches or warnings, but you see the storms there, you can just go straight to the Cape products. And most unstable, that will give you kind of a worst case scenario. And we pull that up and we can see values ranging from 250, and we're looking at the red lines, 250 here on the eastern edge all the way to about 1,000. So this is going to be marginal intensity. Now, of course, the other factor is shear, and you can take a quick look at your helicity. So that'll be under the wind shear page, and then you go to storm relative helicity. We can do a surface through 1 kilometer. That'll kind of give you a good ballpark. 200, that's starting to get up there, but in a very low Cape situation, you need a little bit more shear than that, probably 300 to 400 and above. So if we were looking maybe for an isolated weak cell to produce some severe weather, we would know to maybe look in this area here. Stronger instability, stronger shear, and shear is really what gives you your unexpected situations of some supercell just coming out of nowhere and producing severe weather. Okay, let me take a quick look at chat, and we got Ron here, Southern California, Lexi, Kevin, Michael, and Mark. Hello to all you. Let's see, Lexi, Sue. Anyway, glad you all could join here, and let's go right into the surface analysis. You can see the cold core right here over northwestern Ontario. And some of the warmest air is over Mexico down here. So that's pretty neat. We're kind of like right in between these two areas. And we're going to find the jet stream in between that. The jet stream, where is that exactly? We can go up to 300 millibars, and I've got a chart set up here. There we go. This is actually the 200 millibar analysis, and we can see not only the polar front jet, but also the subtropical jet. It really likes to get established in this anticyclonic flow we have right in this area, right where the ridge is. And that's it right there. Now what I'm going to do here is draw a cross-section. Let's go from just off the coast of Texas all the way up to Winnipeg. I have a data set loaded in here in wind grids. And let me go ahead and set up that cross-section. I'll go to Map Select, and I'll do that right there. And then generate that. And then I've got a product set up here. Where we can display that. Okay, 6-hour forecast, so that's right now. Okay, good. Now, I realize this chart is getting a little bit cluttered, but we'll just kind of keep it simple. Vertical is your height, so 850 millibars right here. You can see 500 labeled right here. That's 18,000 feet. And then 200 millibars, which is up at about 40,000 feet, right up here at the top. Now the brown lines, these are isotropes. You can picture them as temperature contours at a specific millibar height. And also, if you sync a parcel adiabatically to a given region, to a given level, like right here. If you sink this parcel down to this level, then you can kind of compare them horizontally. So it's basically just it's a good way of looking at temperature, removing the effects of height and differing pressure. The yellow lines, those are going to be your isotachs. So that's areas of high wind speed that are going to be circled here. So we have our polar front jet over here and our subtropical jet here. Now the other thing that I need to tell you is the east-west. So down here we have the Texas coast. Dallas-Fort Worth is going to be about right here. And Minneapolis is going to be about right here. And then we pick up Winnipeg right there. So what you can see looking at the brown lines, you can see the frontal surface. We look for the tightest packing, even on the cross sections. So there you go, there's the top of the front. And we can kind of trace that upwards a little bit, and that's going to go either that way or that way. Can't really tell here. And this has been kind of a very old frontal boundary. It's been sitting there for many days. And underneath that, we've had this fresh incursion of cold air coming south underneath it. So it's kind of a very complex picture. And then up above, we can see the stratosphere. And that's where you have extremely tight packing, because that's an inversion, and the temperatures are rising very quickly with height, or at least the potential temperature is rising very quickly with height. And I'm differentiating the two because you can have a constant temperature from 40,000 up to 60,000 feet, but with that constant temperature, your potential temperature is going to rise very quickly. So that's kind of what's happening up here. Potential temperature rising very quickly, and that's signifying the stratosphere way up here. Now, what's causing these jet streams? Well, we've got that old polar surface right here, the polar front, and that's causing most of what you see up here, this very wide band. And then the subtropical jet, you can see a little bit of packing right in here. It's kind of like a little front aloft, and that's kind of responsible for that part. A little subtropical jet embedded right there in the middle. Okay, what's going to happen? What kind of changes are we looking at? I'll let you see this real quick. This is a very simple time section. What's the word I'm looking for here? Time series, there we go. So here we're starting out at today, and you can see the frontal inversion right there. And let me run that time cross section. Now we're going to go forward 3 hours. And you can kind of see the changes along that cross section. So there's kind of a reinforcing shot in the lower levels here of cold air. Then you can see it tighten up a little bit here. So maybe a little bit of frontogenesis right there. This is going to be about the around Kansas or Nebraska. Then you can see the polar front jet kind of divide into this split flow pattern here. And now you can really see that frontal surface right here kind of redevelops and sets up right here near the surface in Kansas and Oklahoma, and then deeper in the Dakotas. So anyway, there you go. That's just a little bit of cross-section stuff to look at, since the atmosphere is three-dimensional, and we don't get a lot of that 3D picture just looking at these flat horizontal charts here. So let's do our frontal analysis. This is 500 to 1,000 millibars for right now. And I just cracked open a drink here. It's some sort of water drink I got at CVS, fizzy water. Let me just get my voice back here. I'll take a look at the chat real quick. See if there's any questions or anything like that. Everything looks good. I guess our audio is great. So let's lay down those fronts. Looks like maybe a low pressure area. Is that low pressure here? Can't really tell. I guess it is. So maybe I'll just draw this front here real quick. There we go. And then out in the western U.S., obviously the front is somewhere between Central California and Portland. So maybe I'll just go through here for now. And then it connects up to our next system out in the Pacific. So we got a new frontal system coming onto the west coast right there. And we'll check that out on the satellite picture briefly. There's the polar air over northwestern Ontario. And I'm going to show you a different chart here. I'm going to look at the 850 through 1,000 millibar thickness. So instead of taking the average of the lowest 5 kilometers, we're taking an average of the lowest 1 to 2 kilometers. And here's what the chart looks like. So this kind of gives us an idea of the, looking strictly at the lowest levels. So this will kind of help us find shallow fronts. If they're kind of embedded in this pattern, you might find a little bit of banding further north, and that would be indicative of a shallow front making its way southward. The deepest polar air in the lower levels near the surface, that's going to be pretty much in the same area. Where you do have a difference is if you take a look out west, you can see kind of a very broad, kind of a weak polar air mass at 1,000 through 850, but if you go up to 1,000 to 500, now it stands out even more. So this is telling you that you've got very deep polar air, and it's possibly stronger aloft. So maybe a cold pool aloft, for example. So that's one of the ways you can use the different types of thickness charts that are available. Okay, I was going to look at some of the upper air charts here real quickly. This is an actual analysis for this morning. This is the 200 millibar analysis. This can be useful, especially on a storm day when all the data is really critical and you need to look at all the observations. So you can see we've got some aircraft reports. These are ACARS reports here. There's a balloon launch right there. The circles are balloons. So there's Midland, there's Del Rio, there's Tucson, Albuquerque. And then we have satellite winds. These are actually observed and detected by analysts at INSEP in Washington. So that's even more data. So this is kind of like the maximum observed data. And this is not model analysis. This is strictly observed. On the other hand, when you're looking at charts like this one, 200 millibar height, this is from a model. This is the GFS model here. And even some of the fields from the SPC mesoscale analysis site, these are all from models, believe it or not. I think this is from the, I want to say either the SREF or the HRRR, probably the former. But if I put this on the southeast U.S. and pull up upper air and go to 300 millibars, this is all derived from models, even though it says mesoscale analysis data. Because, you know, if you think about it, if you look at the bottom here, let's see. Let me make sure I'm not giving you some bad data. They may have changed this a little bit since then. I think they may be blending a little bit more observed data. Yeah, okay. I think this, yeah, this is model data. They're showing this is from a 0-hour run here, and that's a 1-hour forecast right there. Either that or it's either that or, yeah, okay, that's a 1-hour forecast. Sorry, I'm kind of stumbling through that. I just wanted to make sure nothing had changed in the way where these charts come from. But anyway, that kind of gives you kind of like a balanced picture using all the fields, and it gives you the benefit of vorticity, of other things that can't be directly observed by the radiosonde data. And there's the 850 millibar chart near that front. And in this case, we're looking at dew points. That's going to be the green lines. And you can kind of see where the low-level moisture field is kind of banked up towards that line of thunderstorms right here. So it's basically tapping this moist air in western Florida right there. Okay, this is a look offshore here showing the water vapor imagery. And this is kind of referred to sometimes as the Pineapple Express in the wintertime when we have very deep tropical air that moves northeastward into the U.S. When you have these cold domes across the central and western U.S., you can get a lot of lift and a lot of ascent and a lot of cloudiness associated with that. And there's been a couple cases of big snowstorms, like that San Antonio 85 storm that dumped 22 inches on them. That was associated with one of these Pineapple Express feeds going northeast across the cold dome in Texas. And a lot of the drier cold air outbreaks that don't have any snow, that's because that and the cold air coming out of Canada are not really in phase. So anyway, with this moving eastward into California and Nevada, we should see some of the precip start to get a little bit of an increase in coverage there over the next couple of days. So I think we're ready to head into the forecast. So let me run the charts back. Okay, I'm going to have to bring up the loop here, and then we will be set. So, starting out with our current chart here, we know the front is down to the south, and then it goes maybe towards Las Vegas and central California right here. So, high pressure, 1028 millibar high over Missouri. And it's pushing a lot of cold air down into Texas. So what's going to happen over the next day? Got a 1036 millibar high over Montana. So higher pressure up north. That means we're going to continue to push some of this cold air southward. So a little bit of a reinforcing shot. And then let's see. Tomorrow, it's already Wednesday. Tomorrow. And there we go. Looks like we're going to get a little bit of frontogenesis right here. You can see that packing of the thickness lines coming together. And that's partly due to cyclogenesis out in this area as this Pacific system comes inland. So we can see all this starting to tighten up. And then by Thursday, good strong low over Wyoming, lee side trough down into New Mexico. And then our surface front down into Kansas, and then northeast into Washington. And here's our Pacific system moving inland. Okay, then Friday, looks like a bit of a snowstorm coming together, just like we had last weekend, and that'll move likely eastward. And here in Texas, we'll probably just get a couple of days of mild weather here. And Saturday, looks like we pick up a norther. So that'll change things a bit and get a norther blow through. Weather system moves into the Great Lakes area right there, and you can see the snow line basically running from central Indiana up to Toronto and out towards Vermont. Front blast through Texas, and a little bit of freezing and frozen precipitation in its wake, so possibly a little bit of that around Dallas and Little Rock on Saturday into Saturday night, and looks like more thunderstorms for the southeast U.S. Now, as far as whether they're severe, that's going to depend on the cape we have available. Let me see if I can pull up a cape product, and I'll launch that in a different window. And while that loads, I'm going to kind of finish this off. So we're going to be looking at the Cape at about 120 hours when we come back to that chart. So basically high pressure moving through the southern U.S. Monday into Tuesday. Then you can see that cyclogenesis set up large area of low pressure in Canada around 19th through 20th. And then towards Christmas, we just run the charts through. Looks like a Pacific system moves into the Central Plains right there. A little shot of cold air coming southward. And there you go right there. Looks like some cold air and then a reinforcing shot around the 26th coming southward. So it looks like a very changeable weather pattern here over the next 2 weeks. And let's check on that Cape. Here's the 60-hour forecast, and there's the values. You can see those at the bottom. The blue range, that gets into the thunderstorm range. Then 2000, that's going to be in the severe range. So we run that forward. There's your Cape starting to come up with that return of surface moisture. And we just don't quite get it. Best we can do for Cape up in the Alabama, Georgia area is about 250 at best, so that doesn't look too bad. Okay, so I think the main concern over the next week or two is just going to be cold weather and chances for snow. Minor chances of snow anywhere from Dallas to maybe Ohio northward. And that chance of snow for Dallas and Little Rock could be on Christmas if that model pans out. Let's take a look at the Canadian model. I went ahead and pulled that up just for the heck of it. This is the GDPS. And let's see what that shows. I'm going to run this back to about 120 hours. Very weak bit of snow there on Sunday night. And that moves into Indiana. Indiana's got some freezing rain right there on the wake of that front moving into Ohio. And then, let me double check that that color scheme. Yeah, Canadian model going for freezing rain in Dallas, Oklahoma City, and Wichita Falls on the 21st. And it actually kind of expands pretty well right there. This is a, let's see what kind of pattern. This is a warm air advection pattern. So that would be associated with freezing rain, and you can see it changes over to rain as the warm air moves northward. So kind of a very pessimistic view right there, 21st, 22nd on the Canadian model. So they're going for freezing rain all the way from Dallas up to Chicago. So basically it starts out right there around Abilene and then moves northward. So yeah, we'll see if that happens. And then for Christmas, model frames aren't quite there yet. We've only got the GFS for that Christmas forecast there. Okay, let me see here. I had a building block segment, and did I get that lined up? I was going to talk about, trying to remember what I was going to talk about. I'm sorry, I'm going to have to skip that for today. I don't have that set up, but we'll do that tomorrow. Sorry, guys. All right, questions from the chat. Is frontogenesis associated with the exit region of a jet streak? Well, we're getting a little bit complicated here, but we can talk about it briefly. I'll just put a jet streak on here real quick. Yeah, the exit region is going to be this area here ahead of the jet streak, and the entrance region is back in the lee side. So the backside does tend to be associated with frontalysis as high pressure moves in, and we are looking for frontogenesis along the exit, because basically the jet streak itself represents where the strongest baroclinicity is. Your low pressure area at the surface is going to be right there, so you're going to be tightening up the gradients out ahead of it as that low pressure moves towards that area. Norther. What's a norther? I'll draw that out real quickly. That's basically just where we have a very strong front moving into the Great Plains. The Central Plains is kind of unusual in the world for the strength of the cold fronts that we get. The temperature changes in 1 or 2 hours can be just phenomenal. And, you know, I've forecasted over in Asia, and I lived in Europe for a couple years, and I've never seen anything like we have here. So that would be the leading edge of a very strong front. And I've seen stronger. It's been a while. I know back in the 80s and 90s we've had some very intense frontal passages come through Texas and Oklahoma, and some of those have been associated with winds up to 50 to 60 miles an hour, and a lot of times you'll get a very long roll cloud developing along the front, and it looks kind of ominous when you look out to the north and see that coming. And like I said, it's been years since we've had a really good blast of what we call blue norther, but this could be a situation where we get this. This is December 18th. We'll see what happens with that. Okay, I guess I'm probably all talked out here, so anyway, I hope you enjoyed the weathercast, and I'll try to get those building blocks ready for tomorrow. And I appreciate you watching. Hopefully we'll see you tomorrow on Wednesday. Thanks.